Okay, this is the video solution to the Get Your Brains Back into Physics challenge problem that I gave the other day. Here's the electron gun with the electron being shot up like this. It traveled around in a path like this due to some unknown force, but you could think of this as a track if you wanted, and if that would make it easier. And then from here it shoots out horizontally and comes down to the ground. And our goal is to find what is this distance from the gun to where it lands. Now, to think about this, we want to divide, as usual, the problem into different segments. And so I'm going to call this point here A and this point here B. And I'm going to separate that right there because this is likely to be a different acceleration than in any of the other parts of the problem. I'll put another point here at C. Again, the acceleration changes at C, and put D because that's the endpoint that we are interested in. Now when I track backwards, I look here and say this looks like sort of a two-dimensional motion, projectile motion kind of problem. And knowing what I know about how far it falls and accelerations and things like that, I need to know how fast it's going here, because that's going to tell me how far it's actually going to get in the amount of time it takes to fall. And if I'm going to find out how fast it's going here, then I probably need to know how fast it's going at B, and then I'll have to do some physics to find out how fast it's going at C. Then from A to B, I think is the spot that I'll start. And so just making a list of variables, so velocity at A, velocity at B, acceleration A to B, delta y from A to B, and time from A to B. Zero, unknown, that's 1.2 meters, and unknown. That's too many unknowns to make any progress with. On the other hand, we do know that we do know the amount of force on the electron going up the barrel. And so perhaps to get at the acceleration, we can use a force approach. Maybe a net force equation can deliver us the acceleration. So let's try that. Before we do that, we want to draw a free body diagram. There's an upward force from the gun on the electron. And here's the downward pull from the Earth, I'll use a capital E, on the electron. And so our net force equation looks like this. Force gun on electron minus the weight of the electron equals ma. Do some substituting here. This is given as 197 times 10 to the negative 31 newtons. And this is going to be g times m, or 9.8 times the mass of the electron. 9.11 times 10 to the negative 31. And that should then equal the mass, 9.11 times 10 to the negative 31 times acceleration. And if I put all those numbers in and calculate them out, I get 11.82 meters per second squared for the acceleration. We'll pick up the next part of the problem in the next segment of the video.